get ready to the count.
Sudah start belum? Okay, Assalamualaikum dan salam sejahtera. Hai semua para guru, ibu bapa yang dihormati dan para pelajar yang cikgu kasihi sekalian. Selamat datang ke Pusat Tuisyen Akademi YouTuber AYU, Usaha-sama E-Didik Malaysia dan Kelab Guru Malaysia. Ingat hashtag bermula percuma, selamanya percuma. Untuk mendapatkan keberkatan kelas kita pada petang ini, bagi yang beragama Islam, marilah kita bersama-sama memulakan kelas dengan membaca umul kitab Al-Fatihah, dan kepada yang bukan Islam bolehlah bertafakur sejenak. Okey, Al-Fatihah. Bismillahirrahmanirrahim. Okay, apa khabar para pelajar yang guru-guru kasihi semua? Harap semuanya berada dalam keadaan baik dan bersedia untuk meneruskan kelas kita pada malam ini. Cikgu percaya pelajar-pelajar dah tak sabar untuk mengikuti kelas kimia perayu khusus untuk STPM dan matrikulasi. Jadi cikgu perkenalkan diri dahulu. Cikgu ialah Madam Rosmaya dari SMJK Yuhua Kajang, Selangor, selaku moderator pada petang ini. Jadi pada petang ini kita bersiaran secara langsung dari channel Cikgu Vivi Lau. Sesiapa yang belum subscribe beliau, silalah tekan butang subscribe sebagai tanda sokongan kepada Cikgu Vivi Lau. Untuk makluman pelajar semua, nama penuh beliau ialah Cikgu Lau Chai Wee dari SMK Tinggi Klang, Selangor. Tajuk yang akan disampaikan oleh beliau ialah Periodicity Siri kedua. Sambungan daripada topik minggu lepas. Pelajar dan para penonton lain dialu-alukan untuk mempelajari topik berkenaan. Jadi kelas ini akan berlangsung lebih kurang 1 jam. Jadi bersama cikgu di studio pada petang ini ialah Cikgu Tang dari College Matrikulasi Selangor, selaku konsul host pada petang ini. Cikgu Mawar, belum ada lagi sini Cikgu Mawar dari KPM sebagai pemerhati. Jadi sebelum kita teruskan kelas kita, suka cikgu ingatkan semua pelajar dan penonton yang ingin menghantar komen agar menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk kepentingan umum. Cikgu percaya semua yang hadir kelas pada petang ini merupakan pelajar yang cemerlang, dan jom kita tunjukkan disiplin yang baik. Sila fokus pada isi pelajaran yang akan disampaikan oleh Cikgu Vivi Lau dan gunakan ruang chat untuk menjawab soalan atau jika ada soalan yang hendak diajukan. Jadi pada akhir siaran ini, link isi dia akan diberikan bersama kod access. Pastikan anda menggunakan email e-didik. Dan satu perkara baru, ada masa ganjaran kredit kerana mengikuti kelas Tuisyen AYU. Dan anda boleh menebusnya dengan hadiah yang istimewa. Anda perlu memohon ID e-didik junior terlebih dahulu sebelum mengisi borang dalam klaim kredit tersebut. Jadi link untuk memohon ID e-didik junior dia akan diberikan semasa kelas berjalan nanti. Jadi anda semua bolehlah mengisi borang klaim kredit apabila diberi link di akhir kelas. Jadi kod untuk klaim kredit ini ada 4 digit. pastikan anda mencatatkan dalam kertas. Nanti akan diberikan oleh Cikgu Vivi Lau. Okey. Jadi tanpa membuang masa lagi, Cikgu serahkan kelas kita kepada Cikgu Vivi Lau. Dipersilakan.
Okay. Thank you, Cikgu Rosmaya. Good evening to all the students and teachers. Today I'm going to continue periodicity. Before that, I like to thank Teacher Tang as the control host for today's online class, Teacher Rosmaya as the moderator, and Teacher Mawa as the observer. Okay. First let me introduce myself first. Okay, today we will look at chemical properties. Okay, so I'm from Pusat Tingkatan 6 SMK Tinggi Klang. My YouTube channel is Vivi Lau. Okay, then for our PU team, we have Maths department, which is led by Teacher Im, and Biology PU, which is led by Cikgu Faiza, and Physics, which is led by our moderator today, Madam Rosmaya. And next we have Accounts and Economy. The Ketua Panitia is Madam Fizi. And lastly, we have Chemistry, which is led by Cikgu Shannon. Okay, so these are the learning objectives for today's topic. So we are going to learn about the reactions of period 3 elements with oxygen and water, interpret the ability of elements to act as oxidizing and reducing agents, explain the acidic and basic properties of the oxides of period 3 elements, describe the reaction of the oxides of period 3 elements with water, describe the classification of the oxides of period 3 elements. Okay, so let's begin our lesson today. So this is a periodic table of elements. Okay, so we look at the first one.
Cikgu Lau, boleh umumkan kod yang pertama dulu.
Kod yang pertama, okay. Kod yang pertama 7251. Betul kan? Cikgu Rosmaya, betul? 7251.
Betul.
Betul, okay. So thank you. So we look at the slides. So we have for the group, for the alkaline metals and alkaline earth metals, group 1 and group 2 elements, they will react vigorously with oxygens to form metal oxides. Okay. The picture shown here is water. Okay. So the reactivity of the metals decreases in the order of from sodium, magnesium to aluminum. So sodium is the most reactive because of the size. Across the period, the size decreases. Okay, so this is a general. These are the equations for the reaction of the period 3 elements with the oxygens. Yes. So sodium, magnesium, aluminum, silicon, phosphorus, and sulfur are all burned in oxygen to form an oxide. Okay. So the valence chemical equation are as follows. So we have sodium react with oxygen, form sodium oxide. So you have to know the products and must balance equation. You don't need to write the physical states. For semester 2, the first 2 chapters for the equation must write the physical states. But for the chapter 3 onwards, the physical states are not important. So if you write, you must write the correct one, and you must write complete and correct physical state. So you don't write also okay. So the reaction require heating. So sodium, magnesium, aluminum, they will react vigorously form the oxides. Okay, so silicon is more difficult to react. and form the silicon dioxide. Okay. Phosphorus also will react vigorously and form the P4O10, and sulfur form the sulfur dioxide. Okay, so we look at each one. Okay, so first we look at reaction of sodium with the oxygen. So for the So for sodium, it will burn readily. So it's a vigorous reaction. In oxygen, with a bright yellow flame, okay, to produce a white solid mixture of sodium oxide. Okay, so we have sodium oxide and sodium peroxide. But in the exam, you can just write one, just write sodium. 4 sodium reacts with 1 mole of oxygen, form 2 mole of sodium oxide. Write this one enough for it. So the flame is yellow flame. You can see the color of the flame. Okay. For next one, magnesium. Okay, so magnesium also reacts vigorously. So it will form brilliant white flame. It will burn with brilliant white flame. So you can see here, the color is very nice. Okay, so it's a brilliant white flame. So from the oxide, which is white color. Sodium oxide also white color. Okay, so sodium peroxide is yellow. Okay, so we look at aluminum. Okay, for aluminum, it will react readily with A at room temperature to form a protective layer we call aluminum oxide. So this one is a protective layer. Okay, so when powder aluminum is heated strongly, it will react with oxygen to form aluminum oxide. Okay, so this is a white, also white color flame. Okay, you can see it's a white flame, also like the magnesium. Okay, the aluminum oxide also white powder. Okay, next we look at redox properties. So from the electron potential, you can see that, okay, sorry. So from the electron potential, you can see that more negative electron potential value will be a strong reducing agent. Okay, so because of that, across the period, the element getting become non-metal, right? From metal become non-metal. So means reducing power will decrease. Okay, the value will become more positive. So like you learn in chapter electrochemistry. So when the electron potential more positive, it will undergo reduction. So it will become a stronger oxidizing agent. So across the period, element becomes a stronger oxidizing agent and weaker reducing agent. Okay. So look at the value of the sign of the electron potential. More negative, stronger reducing agent. More positive, stronger oxidizing agent. Okay, so so sodium, magnesium, and aluminum are strong reducing agent. So that's why they will react vigorously with the oxygen. Okay, because they are strong reducing agent. So they will donate electron. Okay, they will readily give up their electrons from the outermost cell to form positive ion. Okay, so oxygen act as a oxidizing agent. So oxygen accept the electron, so form oxide ion. So they will combine form the white oxide powder. Okay. So far, any question? Cikgu Osmaya?
Okay, no question.
Oh, no question. Okay, thank you. So we continue. So just now, the electron potential value show the strength as the reducing agent decreases in the order from sodium to aluminum. Hence, the reactivity of this metal decrease in the order, okay, from sodium to aluminum. Okay, so next we look at reaction with oxygen for the non-metals. So for the non-metals, they are weak reducing agents. So silicon is the weakest reducing agent. Okay, because of the silicon is giant covalent structure. So it reacts slowly with oxygen, So it burns in oxygen at the red heat. So you can see here, the flame is red color and form the white powder also, white silicon dioxide. Okay, so the equation from SiO2. Okay, then we have phosphorus. Phosphorus is more reactive. Phosphorus burn readily in oxygen, white flame. So you can see here you can see it's white flame to form the either P4 or 6 or P4 or 10. So P4 or 6 is formed when we have limited supply of oxygen. So from P4 or 6. So if we have excess of oxygen, we'll form the P4 or 10. Okay. So P4 or 10 is white film. So this is a structure of phosphorus P4 and the P4 or 6 and P4 or 10. Okay, for sulfur, it will burn readily also. Okay, just gentle heating, it will burn with blue flame. So it's very beautiful color you can see here. Okay, so forming the colorless. So remember the sulfur dioxide is colorless. This one will ask. So it's sulfur dioxide is colorless. So it burn in blue flame. Sulfur burn in blue flame and form the colorless sulfur dioxide gas. Okay, so sulfur trioxide is produced when the sulfur dioxide react with oxygen with the presence of the V2O5 to form the sulfur trioxide. So must have the catalyst V2O5. Okay, so you have to memorize the catalyst. So the equation is a reversible reaction. Okay, next we have chlorine. So chlorine is a strong oxidizing agent, so it will not react with oxygen gas. Okay, oxides of chlorine cannot be prepared by the reaction of chlorine and oxygen. Argon is a noble gas and also does not react with oxygen. Okay, so these two cannot react with oxygen. Okay, so first question. So student, you can try to answer the question and write in the chat box. Which element in period 3 does not react with oxygen? So very easy. We just learn about that. So any answer from the students? The group also, yeah?
Okay, student, come on. Okay, you can write the answer in the chat form there. Okay, anyone with the answer? Okay, got one student here from Chi Sin Chai B.
Yeah.
Okay.
B. Okay, very good. So the answer is B. Okay. So chlorine, strong oxidizing agent cannot react with oxygen. Okay. Next question. Question 2. So we have 3 elements here, X, Y, and Z from period 3. So the reactivity towards oxygen, you can see X does not react with oxygen, Y reacts slowly, Z reacts vigorously. So try to arrange the elements according to the ascending order of their proton number. Okay, so ascending order of their proton number.
Okay, students, can write there in the chat box there the answer. Okay, we have one answer here from Chi Sin Chai, D.
Okay, D. Okay, very good. How about other answer? Other
Mm,
students?
no more answer right now.
So, okay, correct. So the answer is D. So you can see Z reacts vigorously. So means it's a metal. Okay. So Y reacts slowly. X chlorine argon does not react. Okay. So Z, Y, X are correct. Very good. Okay. So we look at reaction with water. Reactions of period 3 elements with water. So sodium reacts vigorously with water. Okay. So reacts vigorously at room temperature, producing hydrogen gas and a colorless solution of sodium hydroxide. So if observation, you can say the water slippery and give turn the red litmus paper blue one, okay, because it's alkaline solution. Okay, so the observation, if question asks for observation. Okay, so you can see the equation here. So you have the right balance equation. 2 more of sodium reacts with 2 more of water, form 2 more of sodium hydroxide plus hydrogen gas. You no need to write the physical state. If you want to write, must always write the correct and complete one. Means reactants must write, products also must write the physical states. Okay, so you can see the next one. So this is an experiment you have done. I think your teacher show you right in Form 4. Okay, so when a small piece of sodium is added to water, so we just use small piece because it's very reactive. The heat of reaction melts the metal to a silver color globule, so it becomes a globule. Okay, so you move around on the surface with a hissing sound. Okay, if too big, you cut too big piece, it will, you can see it will explode. Okay, so just cut a small piece. Okay, then magnesium has a very slight, okay, reaction. Means not very reactive at room temperature, okay, compared to the sodium. But it will react vigorously with steam. Okay, so the experiment we use is we heat up the water soaked in the cotton wool. So the steam produced will react with the magnesium and form white flame, burn in white flame. So produce the hydrogen gas. So you burn the hydrogen gas here. Okay, okay, so this is a experiment. Okay, so if you use a clean pure magnesium metal, okay, drop into the cold water, okay, cold water you will get the magnesium coil covered in small bubbles. So the reaction not so reactive. If you use a room temperature or cold water. Okay, so the hydrogen gas will accumulate at the surface here. Okay, magnesium hydroxide is formed as a very thin layer on the magnesium. Okay, magnesium hydroxide is formed thin layer on the magnesium, so you can see white color. So it will stop the reaction. Okay, aluminum is not attacked by water or steam because aluminum reacts readily with the oxygen in the air, so it will form a protective layer, protective oxide surface, very thin film. Okay, so it will protect the metal from attack by the water. Okay, so this thin film is non-porous, means the water cannot go through, or we say impervious. Okay, so if you remove the protective layer, okay, let's say you remove by the rubbing with mercury to form aluminum, mercury, and manganese. So here you can see the reaction between aluminum and mercury. Okay, so aluminum in the amalgam will react vigorously. Aluminum in the amalgam will react vigorously with water at room temperature to form aluminum oxide and hydrogen gas. Okay, this one is not so important. because normally you just need to know the aluminum not so reactive with the water in room condition because of the protective layer. Okay, this one, and raise the question say you use a pure aluminum powder. If pure one, it will react slowly. Okay, like this one pure aluminum without the aluminum oxide. Okay, so this one is a aluminum amalgam. Okay. Okay, so we look at the silicon, phosphorus, sulfur, and argon do not react with water or steam. So these four will not react with water or steam. Okay, but chlorine can react. So chlorine dissolves in water to form chlorine water. Green solutions, which consists of two types of acids. Okay, two types. Hydrochloric acid or chloride 1 acid. Okay, so chloride 1 acid is this one, HClO. We also can see say chloride hypochlorous acid. Okay, hypochlorous acid or chloride 1 acid. Okay, so this is a disproportionation reaction. Okay, disproportionation reaction. Okay, you can see the chlorine elements undergoes oxidation and reduction at the same time. So you can see the oxidation number. So chlorine is 0. So oxidation, it will form positive 1. Okay, the oxidation number increase. So reduction, it will form negative 1. CO negative here. So it's a chemical reaction. This proportionation is a chemical reaction in which the same substance simultaneously oxidize or reduce. Okay. Okay, so question number 3. So students try to answer this one. Some physical and chemical properties of element X are given below. So insoluble in water, burns in oxygen to form acidic gas, able to oxidize magnesium. So what is element X?
Okay, maybe while waiting for them to answer, we can announce the second code. This now the first code, second code. Or I can help you to announce the second code.
Please help me.
Okay. So the second code, student, you jot down. Okay, it's number 2. Okay, I repeat, number 2. Okay, the first one announced already. Okay, so let's see, student, any answer from this question?
So insoluble in water. So burns in oxygen form acidic gas, able to oxidize magnesium.
Looks like no answer yet from the students.
So can form acidic gas means gas should be non-metal, right? Okay. Acidic gas. Okay.
Okay, any answers, students? Okay, we have one answer from Prishita Murali, C.
Okay, C. Very good. So the answer is C. So sulfur will form. Sulfur is insoluble in water. Okay, so it will react with oxygen, form the sulfur dioxide. So this sulfur dioxide is acidic. Dissolve in water, form the sulfuric acid. Okay, so it can oxidize the magnesium. Okay, so we look at now we look at the oxides.
Okay, now Okay, Cikgu Vivi Lau, would you like to take a break now?
Okay, thank you.
Okay.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, Cikgu Vivi Lau, you can start the second round.
Okay, thank you, Cikgu Rosmaya. Okay, so now we look at properties of the oxide of the elements of period 3. So we have this table, okay. So the oxide of the period 3, we have sodium oxide, magnesium oxide, aluminum oxide, SiO2. For phosphorus is P4O6, P4O10. Sulfur we have SO2, SO3. Cl we have CO2O and CO2O7. Okay, then the oxidation number you can calculate. So for the group 1 is positive 1, group 2 positive 2, group 13 positive 3. So silicon is positive 4. Phosphorus we have positive 3 and 5. Then sulfur we have positive 4 and 6. So this one how to calculate now? So P4O6 is the compound is 0. Okay, so the oxygen always negative 2. Okay, so we have 6 negative 2, so negative 12. So means you need another 3 times 4, 12 minus 12, so you get positive 3. The same way for calculation of the oxidation number for P4 or 10. So we'll get positive 5. So sulfur dioxide is positive 4 for sulfur. For sulfur in sulfur trioxide is positive 6. Okay, then Cl2O is a positive 1, Cl2O7, the Cl is positive 7. Okay, then the structure for the metal oxide is ionic structure. Okay, for the non-metal oxide is simple molecular structure. Silicon is giant covalent structure. Okay, then chemical bonding, ionic bond for the metallic oxide. So covalent bonds between atoms for the silicon dioxide. Then for the oxides of phosphorus, sulfur, and chlorine, they have weak van der Waals forces between the molecules. Then the relative melting point, sodium metallic oxide has ionic bond, so it's high. Then giant covalent structure is very high. Okay, weak van der Waals forces, so it's very weak, so it's low. Okay, so the classification of acid-base nature. So we have basic. So all the sodium and magnesium oxide are basic. Then aluminum oxide is amphoteric. Silicon is acidic, silicon oxide. Silicon dioxide acidic. Then oxides of phosphorus, sulfur, and chlorine acidic. Okay, so the basic oxide and acidic oxide, they are soluble. Okay, aluminum oxide insoluble, silicon dioxide insoluble. Magnesium oxide slightly soluble, okay, sparingly soluble. Okay, so we look at the explanation of the structure just now. Okay, so for the metallic oxide, So sodium oxide, magnesium oxide, and aluminum oxide, they have giant ionic structure with strong ionic bonds between the positive ion and the negative ions. So this strong ionic bond is very strong, so we need a lot of energy to break them. So they have high melting point. Okay, silicon dioxide has giant covalent structure with strong covalent bond between the atoms. So we also have very high melting point, higher than the metallic oxide. Okay, then the simple molecular structure has weak van der Waals forces between the molecules. So less energy is required to break the weak bonds. So they have low melting point. Okay, so we look at the hydrolysis of oxides. So what is hydrolysis? So from the words, lysis means breaking of the bond. So hydrolysis break by water. So it's a chemical reaction of a compound with water. Okay, so the water break the bonds in the structure. Okay, so sodium oxide are ionic, so they can soluble in water. Okay, so they will form alkaline solutions. Okay, with the pH value 11 to 14. So this is the equation. So from the sodium hydroxide balance equation. Okay, magnesium oxide, remember sparingly soluble. So sparingly soluble. So also form alkaline solution, but because it's sparingly soluble, so weaker alkali. So 9 to 11 only at pH. So you form the magnesium hydroxide solid. Okay, aluminum oxide has a giant ionic structure with this one. So remember this high degree of covalent bonding. Okay, so this one means the aluminum has high charge density. Aluminum has 3 positive, right? So it will okay. Uh, so it will distort the clouds of oxide ion. Okay, so it will have certain degree of covalent bonding between them. Okay, because they're sharing electrons. So because of that, it's insoluble in water. Does not react with water in room temperature. Okay, does not react. Remember, and it's amphoteric. Okay, so amphoteric means it can react with both acid and base. Okay, because it has covalent character and ionic character. So amphoteric. Okay, then silicon dioxide, giant covalent just now. Okay, so insoluble in water, does not react with water in room temperature. It doesn't have basic properties, so it's a weak acid. Weak acid. Okay, this one we have phosphorus oxides. Okay, phosphorus oxide reacts vigorously with water to give acidic solutions. So we have phosphorus 3 oxide. Okay, uh, 3 oxide, P4O6. This one. Okay, it dissolves in cold water to form dissolve. Okay, phosphorus acid. Okay, you have to remember the name. Okay, sometimes the question asks you to name the products, then you have to write the names. If the question say write the formula, set the formula, you just write formula. Okay, so it's a weak acid, phosphorus acid. Okay, then phosphorus 5 oxide, P4O10, dissolved in water, okay, to form phosphoric acid. Okay, so this is phosphoric acid, H3PO4. So it's stronger acid than the H3PO3. Strong acid, pH value 1, strong acid. Okay, next we have sulfur dioxide. So sulfur dioxide, fairly soluble in water. Okay, reacts with water to form sulfurous acid. So remember the name. Okay, H2SO3 sulfurous acid. pH value of 1. Okay, sulfur trioxide reacts violently. Okay, very reactive reaction with water to form a fog of concentrated sulfuric acid droplets. Okay, so form strong acid. So reacts with water to form sulfuric acid. Okay, so this one should be sulfuric acid. Sulfuric acid. Okay, so the equation, 1 mole of SO3 form 1 mole of water form sulfuric acid. Okay, so far any question from the student? No question. Okay, so I continue. Then we have oxides of chlorine. So we have oxide of chlorine, just now the Cl2O, okay, like chlorine monoxide. Okay, so like chlorine monoxide is a yellow gas. Yellow gas react with water to form chloride 1 acid. Okay, remember the name. So when you write the name, be careful. The oxidation state is a Roman number, so must join up. If you write spacing here, means wrong. So chloride bracket 1 acid. Okay, so HClO. Balance equation. Okay, then second is chlorine dioxide, ClO2. Okay, so chlorine dioxide is a reddish yellow gas. Okay, so reacts with water to form chloride 3 acid. Chloride 3 acid and chloride 5 acid. Okay, so again, the Roman number, no spacing between the name. Okay, so chloride 3 acid is HClO2. Okay, oxygen always -2, so -4. Okay, so the whole thing -1, right? So means this one is 3, +3. Cl is +3, so HClO2. Then chlorified acid is HClO3. Okay, last one we have like chlorine heptoxide, like Cl2O7. So like chlorine heptoxide dissolves in water to form chloride 7 acid, HClO4. Okay, so remember the type of oxides. So chlorine have 3 types. Then remember the acid form. Remember the name and the formula. Okay. So like chlorine monoxides, chlorine dioxide, and like chlorine heptoxides. Okay, Cl2O7. So Cl2O reacts with water forms HClO, chloride 1 acid. ClO2 reacts with water form HClO2, chloride 3 acid, and HClO3, chloride 5 acid. Then like chlorine heptoxide, Cl2O7. Sorry, this one has mistake. ClO2, this one is ClO2. Okay, so this one Cl2O7. Okay, so let's check balance. Okay, balance one. So this one times 2. Okay, so, so this one 2ClO2 plus water and form HCl2 plus HClO3. Okay, so this one has mistake. Okay, next one, reaction of sodium oxide and magnesium oxide. Okay, so sodium oxide and magnesium oxide is soluble in acid but insoluble in alkalis. Soluble in acid because they are basic oxide. So they cannot react with alkali. Okay, so they dissolve in acid to form salt and water. Okay, so for example, sodium oxide react with hydrochloric acid form sodium chloride and water. Magnesium oxide reacts with sulfuric acid form magnesium sulfate and water. So they have properties of an alkaline. Okay, aluminum oxide is anhydrous oxide. So it can react with both acid and alkali. It does not react with water, okay, but react with both acid and alkali. So it will form aluminum chloride with the hydrochloric acid and also form water. It can react with sodium hydroxide to form sodium aluminate. Okay, so this one, remember the formula of aluminate. This is a name, sodium aluminate. So the formula Al bracket OH 4 negative. So remember this one. So it's an hydrochloric, the aluminum oxide. So balance the equation correctly. So 1 mole of aluminum oxide reacts with 2 mole of hydroxide ion and form 3 and also plus 3 mole of water from the 2 aluminate ions. Okay, so this one important. Okay, then we have silicon 4 oxide, or can say silicon dioxide. Okay, so this one no spacing because I change. Okay, okay. So this one no bracket. Okay, so silicon 4 oxide does not react with water or acid. Dissolve in hot. Okay, does not react. Dissolve in hot concentrated sodium hydroxide to form sodium silicate and water. So remember this one, sodium silicate. Sodium silicate. That's not aluminum. Right? So this one sodium silicate. So the formula SiO3 2 negative. So balance the equation. So 1 mole of SiO2 plus 2 mole of hydroxide ion form 1 mole of silicate ion plus water. So if you write sodium hydroxide, means you have to write sodium silicate here. Okay, so far any question from the student?
So far, no question from the student.
Okay, so
I think we
continue.
can announce the third code, The third code.
Oh, okay.
Okay. So I help you to announce, So the third code, student, okay, is number 5. Okay, third code, number 5. Okay, Cikgu Lau.
Okay, so we look at phosphorus, sulfur, and chlorine. So phosphorus, sulfur, chlorine oxide does not react with water or acid. Okay? But they can react with alkali because they are acidic oxide. Okay? So they can react with alkali. React with alkali from water and salts. Okay, for example, P4O6 plus P4O6 is liquid, okay, but you don't need to write physical state. So plus 12 sodium hydroxide from sodium phosphate 3. Okay. So remember the name, sodium Na3PO3. So P4O6 from PO3, P4O10 from PO4. Okay. Sodium phosphate 5. Okay. Oxides of sulfur, sulfur dioxide plus 2 mole of sodium hydroxide from sodium sulfide. Okay. SO3 sulfide. If SO3 react with sodium hydroxide form sodium sulfate, SO4 is sulfate. Okay, for the chlorine oxide, so Cl2O, okay, Cl2O plus sodium hydroxide form NaOCl. Okay, correct one. Okay, this one Cl2O7, Cl2O7 plus 2NaOH from 2NaClO4. Okay, sodium chlorate 7. Okay, plus water. Then Cl2O7 here. Now Cl2O is gas, Cl2O7 is liquid. Okay. Now we look at the last part. Last part of today's lesson. Classification of the oxides of period 3 into basic and phosphoric and acid based on their reaction with water, acid, and alkalis. Okay, so this one just now you have seen. So I show it again. Just now we have discussed this one. Okay, so you can see here the metallic oxide, sodium oxide, magnesium oxide. Okay, they are basic. Aluminum oxide is amphoteric. Then silicon dioxide is acidic. Okay, all the non-metal oxide, phosphorus oxide, sulfur oxide, and chlorine oxide, they are acidic. Okay, so this is the classification. Okay. Okay, so the basic oxide from the group 1 and group 2 elements, except the barium, group 2 except barium. So B is barium. So basic oxide is an oxide that reacts with acid to form salt and water only. So for example, magnesium oxide react with acid form the magnesium chloride and water. Okay, amphoteric oxide is an oxide that can react with both acid and bases. So example, aluminum oxide can react with alkali, form the aluminum ion. React with acid, form the aluminum chloride, aluminum trichloride, the salt, and water. Okay, acid oxide are the non-metal oxide. So they are the oxide that can react with alkali to form salt and water only, non-metal oxide. So for example, the silicon dioxide reacts with hot concentrated hydroxide ion to form silicate ion plus water. Okay, any question? No. Okay, so we look at the question. Okay, so question number 4. Which element has an oxide which dissolves in water to form acidic solution? So which element has an oxide dissolved in water to form acidic solution? Very easy question. So Cikgu Rosmaya, any answer?
Not yet. Come on, student. What is the answer, student? Okay, Eng Chia Ying answer A. The answer given by Eng Chia Ying is A.
Yeah. Any other answer? So the question say dissolves in water from acidic solution.
Okay, Chai, Gao Ming Chai also A. Still A the answer.
Acidic solution, student. Okay, who
Okay, Ibu Lau, given the clue already.
acidic solution. So it's
Okay,
no
any
metal
other?
oxide or metal oxide from acidic solution.
Okay, got one more answer from Zi Xin Chai. D. The answer.
Okay. So the correct answer should be C. Okay. Because dissolved in water. Silicon does not dissolve in water. Okay. So the answer should be C. Although this one can form acidic solution, but sorry, this one silicon dioxide does not dissolve in water, so cannot form acidic solution. So only phosphorus oxide form the phosphoric acid. Remember, phosphoric acid and phosphoric acid to form acidic solution. Okay. P4O6 form phosphorus acid. P4O10 dissolve in water form phosphoric acid. This one silicon does not dissolve in water. So aluminum and sodium metallic oxide, they form basic solution. Okay, second question. So an oxide X has a melting point of 1600 degrees Celsius. It dissolves in hot aqueous sodium hydroxide, but not in water or acid. So what can be the oxide X?
Okay, we have one answer here from Eng Chia Ying. Okay, A. Okay, the answer given is A.
Answer A. Okay. Try again. So you can look at the melting point. Okay, the melting point is very high. Okay, then this is alkali.
Okay,
So
we
what?
have another answer from Prishita Murali, B.
B.
Hmm.
So okay, see, not in acid. Okay, so B is amphoteric oxide. Aluminum oxide is amphoteric oxide. Try again. No, 26. Okay, 4 minutes.
Okay, Eng Chia Ying give answer D.
D. Okay, so the correct answer should be C. Okay, because you can see it has a very high melting point. Very high melting point is a giant covalent uh, molecule. Okay, then dissolve in hot aqueous sodium hydroxide. So silicon dioxide is a acidic oxide. Acidic oxide will dissolve in alkali. Okay, so due to a giant covalent bond, so it must use a hot alkali. Okay, so cannot dissolve in water or acid. So means cannot aluminum oxide. Aluminum oxide is amphoteric, can dissolve in acid and alkali. Okay, both. Magnesium oxide is metallic oxide, so cannot dissolve in alkali. Okay, they are basic oxide. So metallic oxide dissolve in acid. Okay, so this is not the answer. Okay, P4O10 is a simple covalent molecule, so it's weak weak van der Waals forces. So should have low melting point. So the answer is C. Okay, question 6. The following statements are about aluminum oxide, SiO2, and P4O10. Okay, so which statements are true about the oxides here? So the correct answer, true.
Okay, we have one answer here from Eng Chia Ying, B.
Okay, do you have any other answer?
Maybe the student still thinking. Okay, no answer yet from the student. Okay, we have one answer from Chai Si Sin B.
Yeah, okay.
B.
Okay, so the B answer correct. 1 and 4. Silicon dioxide before ethane covalent oxide. Before ethane is hydrolyzed in water to form H3PO4. Yeah. Okay, which oxide is not hydrolyzed in an aqueous solution? Not hydrolyzed. This is the last question. Okay.
Okay, one last question here. Krishita Murali, answer B.
B, okay, very good. So the answer is aluminum oxide, not hydrolyzed in aqueous solution, okay, and sulfuric oxide. Okay, so that's all for today's lesson. So thank you for watching.
Okay. Okay, terima kasih diucapkan kepada Cikgu Vivi Lau atas perkongsian ilmu yang sangat bermanfaat, mudah difahami dan sangat menarik. Alhamdulillah dah selesai kelas kita pada petang ini. Okay, tahniah diucapkan kepada semua yang setia mengikuti kelas pada petang ini dari awal hingga ke saat ini. Sebelum kita tamatkan sesi siaran langsung hari ini, jadi mohon tutup ruang chat dan klik butang subscribe yang masih merah tu dan aktifkan ikon loceng supaya kamu tidak terlepas sesi kelas yang berikutnya. Okay, sekiranya anda suka dengan apa yang dipelajari hari ini, sila klik like dan share kepada rakan-rakan di media sosial anda. Facebook ke Instagram untuk sebarkan ilmu dan beroleh kebaikan melalui perkongsian tersebut. Okay, sila type done di ruang komen sebelum link sijil akan diberikan sebagai tanda terima kasih daripada cikgu kerana kehebatan kamu menyertai kelas tuition percuma pada petang ini. Okey, sebelum tu kod yang terakhir, kita belum beri lagi. Kod yang terakhir adalah 1. Kod yang terakhir adalah 1. Jadi okey, anda telah dapat kesemua keempat-empat nombor kod untuk tebus mata kredit. Jadi link akan diberikan di ruang komen. Link berikan di ruang komen dan pastikan anda mempunyai ID Junior e-didik untuk menebus mata kredit berkenaan. Okay, link sijil boleh dapati pada bahagian chat juga. Okay, kod akses adalah hashtag kelas AYU e-didik. Jadi sila ambil perhatian, link tersebut akan tamat dalam tempoh setengah jam selepas live. Jadi pastikan anda guna email e-didik sahaja. Okay, sekali lagi saya ucapkan terima kasih kepada Cikgu Vivi Lau atas kelas petang yang menarik ini. Jadi sebelum saya tamatkan kelas pada petang ini, dipersilakan ahli konti untuk memberi sepatah dua kata. Jadi saya persilakan Cikgu Tang terlebih dahulu.
Hi, so all the students, hope you all enjoy the class today. So thank you Teacher Vivi Lau for the wonderful class. So all the best to all the students and please stay safe.
Okey, terima kasih Cikgu Tang. Dan seterusnya Cikgu Mawar, dipersilakan.
Okay, hi student. All the best to student and stay safe. That's all.
Okey, terima kasih Cikgu Mawar. Okey, jadi kelas seterusnya untuk tuition kimia PERCUMA adalah pada hari dan waktu yang sama pada minggu hadapan Ahad pukul 3.30 petang. Okey, jangan lupa. Jadi anda semua dijemput untuk ke portal www.academyyoutuber.com untuk dapatkan jadual tuition dan info yang terkini. Jadi bantu cikgu untuk sebarluaskan kelas tuition percuma ini. Dan usaha ini sebenarnya adalah gabungan guru-guru semua Malaysia, seluruh guru Malaysia dan untuk semua pelajar seluruh Malaysia. Pertama dalam kita menghadapi saat genting sekarang kita nak melawan pandemik COVID-19. Okay, semoga kita mendapat manfaat daripada kelas-kelas yang dijalankan. Ingat hashtag bermula percuma, selamanya percuma. Okey, jadi segala yang baik itu datangnya daripada Allah dan jika terdapat sebarang kekurangan dan kelemahan itu daripada kami semua. Okey, Assalamualaikum dan selamat petang semua. Bye-bye.
Bye-bye.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber.
Dibawakan kepada anda oleh Akademi YouTuber.
Thank you.
Oh, ya.
Thank you, Teacher Tan, Cikgu Rosamaya, and Teacher Mawar.
Okey, sustain. Saya pun first time moderator ni. Mula-mula tadi saya tak